In many cases, when you create an object, you'll want to specify its initial values immediately upon creating that object, even before you use the object within your program. And that's the purpose of constructors. A constructor's job is to take the values you give it and initialize data within the current object of the class that's being constructed or being created. So as you can see here in this version of the account test application, at lines 11 and 12, we're creating two separate account objects, account 1 and account 2. Each is a new object of the account class, and in each case we are passing in a different string value. And we purposely created multiple account objects in this example to demonstrate the fact that each individual account object has its own separate copy of the name of the account, and within each separate copy is a different string value. So if I go ahead and run this application in the debugger, let's go ahead and set a breakpoint here at line 15. I'll start debugging the application. So now both of these account objects have been created already. And if I hover over them, I can actually see the value in each of the objects right here in Tooltips. So for account 1, the name is Jane Green. And if I hover over account 2, we can see the name there is John Blue. Now you may notice down here in the autos window it doesn't show me account 1. That's because it's only concerned with the current line of code that's executing. But if you go to the locals window, it shows you all of the local variables within the main method. So we've got account 1 and account 2 are both local variables within main, and if I expand the node for each of these, we can clearly see two separate account objects with two separate values that were initialized at the time that they were constructed. And we're then using the get accessors of the name property in lines 15 and 16 to show you the contents of those two objects. So if I step over those two lines of code and look at the output window here, once again we can clearly see that there are different values for each of the objects. So not only are we introducing the concept of a constructor in this example, but we're also going to re-implement the name property a little bit from the preceding example as well. So let's take a look at our account class. And the name property now is just a single line of code. And then down below here we have the constructor definition. So let's talk about the two different pieces here. When you have a property like the one that we implemented in the preceding example, where you have an instance variable, a get accessor that simply returns the value of that instance variable, and a set accessor that simply assigns a value to the instance variable, so there's no additional logic code in the get or the set. In such a case, you can use what's known as an auto-implemented property, in which case the compiler will automatically create for you an instance variable, a private instance variable, and the get and the set accessor for that instance variable. So you'll notice here there's no private instance variable in the class at all. We simply have a public string property called name, and we declare that it has both a get accessor and a set accessor, and that makes it a so-called read-write auto-implemented property. I can read a value from it, I can write a value to it, and the compiler generates all the code that is associated with that property to basically make it look almost identical to the code I showed you in the account class of the preceding example. You don't get to see the private instance variable that backs the name property, the so-called backing store as they often refer to it. It's all auto-generated for you, but you use that property exactly the same way as we showed you in the preceding example. Now, down here at lines 9 through 12, we have a constructor for the class. The constructor must have the exact same name as the class. It's not allowed to specify a return type, so between public and account there's no return type. Not even void is allowed in this case. It is public because we do want whoever is creating an object of class account to be able to invoke this constructor. And in this case, the constructor receives one parameter, a string called account name, that will be used to initialize the name property. Notice that we're using the name property on the left side of the assignment here. This is going to invoke the set accessor of the auto-implemented name property. The set accessor will then store the account name into the private instance variable that's auto-generated for us by line 6 property declaration. So the account constructor in this case requires only one piece of information, but of course if you have a more complex class, you can have a comma separated list of parameters that get passed into a constructor when it's called. Now back over here in the account test class, when we say new account and then a string is passed in, that's going to invoke the account constructor that receives a string to perform the task of initializing the object. Now it's important to note that once you create a constructor like the one here at lines 9 through 12, we can no longer create an account object with an empty set of parentheses following the class name. So if I remove the string here in line 11 and I say to build the code, you can see we get an error message saying there's no argument given that corresponds to the required formal parameter account name of the account constructor that receives a string. So basically what's happening here is it's saying there is no constructor that receives no arguments. You have to pass in a string based on the class definition. And the reason for that is once you say to create a constructor for your class, the compiler no longer creates what's known as the default constructor for that class. The default constructor is the one that's auto-generated for you if you define a class that doesn't have any constructors. And the default constructor always receives no arguments and always sets the instance variables to their default values, either their defaults as defined by the language, or if the class itself assigns a default value to an instance variable or to a property as well, the constructor would use those default values that are specified. And we'll see examples like that in subsequent examples in later lessons throughout these live lessons videos. So just summarizing once again, you can define one or more constructors for your class if you would like. If you don't define any constructors, the compiler gives you a so-called default constructor. If you define any constructors, it does not define the default one anymore. And if you want to have more than one constructor, that's known as an overloaded set of constructors. All of them must have the same name as the class, and their parameter lists must be different. And the way they can differ is either in the number of arguments that they require, or the types of those arguments, or if you have the same number of arguments and the same types, the order of the arguments in terms of their types can be different as well. And we'll see examples like that throughout later lessons in these live lessons videos.